Good. Now let's move on and look at a couple of types of word problems. Now, in my locker, you will find uniform motion problems, so I want you to go and take a look at those. I'm not going to go through them here. There are examples of rate uniform motion in the same direction, in opposite directions, and they're round trip problems. So I want you to take a look. These are from Algebra 1. These notes say Algebra 1 on them because they're from my Algebra 1 class, from the end of Algebra 1. And it's the key for the notes, and I want you to go take a look. These are the worked out problems, and it's a very good strategy for setting up problems. We're going to use a very similar strategy in number 7 on this page. Okay, so in solving word problems, and you know this from Algebra 1, the first step is to read and understand, determine which information is relevant and what's a red herring, and always consider drawing a picture. If you can, you should. Pick a variable once you've read, and then go back and write an equation that relates the variable to the other elements of the problem, everything else, except the non-relevant information. And then solve the equation, and then check for reasonableness, which doesn't necessarily mean check your algebra. It means check the answer to make sure it makes sense. Okay, so you should take some time to go back and look at those uniform motion problems. It's a 3 or 4 page handout in my locker. And now we're going to look at consecutive integer problems. What I've done is I've gone and I've picked out the typical problems that you'll see in your book, on the test, and in your worksheets. So we've got some consecutive integer problems, we've got a mixture problem, and then the motion problems. You may see other things, but these same techniques can be applied. Okay. A triangle has a perimeter of 27 centimeters, and again, I like to draw a picture. It looks like an equilateral triangle, but we'll assume it's not. Okay, 27 centimeters is the distance around, the sum of the lengths of the sides. The sides have lengths in centimeters that are odd consecutive integers, consecutive odd integers. What's the length of the longest side? Okay, so let's pick a variable. Let's call the shortest side x. So the next odd integer after x must be x plus 2 because x plus 1 is even. The next consecutive odd integer must be x plus 4 because, well, that just makes sense. So the sum of these sides is the perimeter, which is 27. So now we know x plus 2 plus x plus 4 equals 27. There's our equation, and now we're going to solve it. Okay, we need to combine like terms. We've got 3 x's, and we've got constants 2 and 4. We're going to isolate our x term. And now we want just one x, so we're going to divide by 3. So the length of the shortest side is 7 centimeters. Now, was that the question? No, it was not. We have not yet answered the question, what is the length of the longest side? Well, the longest side is x plus 4. So longest side equals is 11 centimeters. Now, when you're taking STAR test or the SAT, and you get your solving, often you'll come to this point where you say, aha, I've got x. Well, x will almost always be one of the answers because they know that sometimes you forget to go back and read what the actual question was. So make sure you follow through by going back and checking what the question was. Okay. Mixture problems. Now this is where we're applying a similar method to what we use for rate times time equals distance in our uniform motion problems on the handout. In that case, you'd have your bike or your people or your plane or your train, and you'd have rate times time equals distance, and your equation would be over here. It would be how these distances relate to each other. In this case, we have a mixture of peanuts and cashews, and we want to make 20 pounds of mixed nuts. So our items are peanuts and cashews, and we know how much in terms of weight we have, the amount, and we know the cost. So if we have the amount and we have the cost per unit, then amount times cost is the total cost for that item. So this setup is very similar to the rate times time equals distance. So how many peanuts, oh, and let's put the mix down here. How many peanuts do we have? Well, we don't know. They don't tell us. It says how many pounds of each kind of nut. So that's one piece of information that's missing. So let's put X. We know we want the total mix to be 20 pounds. So since I'd like to keep this in one variable, I can make cashews 20 minus X. I know it has to be 20 minus X. Now, what's the cost of peanuts? Peanuts cost $4.80 a pound. And cashews cost $8 a pound. Okay? And we want the total mix of nuts to be $6.20 a pound. Alright, so now I've already done the multiplication. I don't want to take the time to do it right now. So X times 480 is just 480X. We're just multiplying across now. This is 8 times 20 minus X. And this is 20 times $6.20, which is 24. So here is our equation, right there. And we can put this together, 4.8x plus, let's go ahead and distribute this. Well, I'll put it down here, 20 minus x equals 24. There's our equation. Now that's 4.8x plus 160 minus 8x, because I'm distributing my 8, equals, I said 24. It's 124. My mistake. I apologize. Yeah, and you should have known that 20 times 6, 20 couldn't possibly be 24. If you caught that, if you'd caught that in class, you would have gotten a piece of candy. Okay, equals 124. Okay, now 4.8 minus 8. We're going to combine our like terms. That's negative 3.2x. 124 minus 160 is negative 36. I combined two steps there. I combined my like terms and I isolated my x term at the same time. If that's confusing for you, go ahead and combine your like terms and then say plus 160 equals 124 and then subtract 160 from both sides. Okay, and then if we divide both sides by a negative 3.2, we're going to get a positive number.